This set of questions is all about how we use and apply our laws of surds. If you haven't watched the video about how to simplify with surds, I suggest you do that first of all. So what we're going to do is we're going to use our laws of surds to simplify some expressions in a variety of different ways. Question number one, you can see that we've got a surd on the outside and on the inside of a set of brackets. So just like we would with an algebraic expression, and we like to expand the brackets, we're going to multiply these out. So we're going to multiply each of the things inside the brackets by root 2. Now root 2 times root 2, we could write that as root 4, but we know that the square root of 4 is just going to be 2. Or when you times a root by itself, you just get that value inside the root. And then the second term would be root 2 times 3, which would be 3 lots of root 2. And again, we've got two different terms there. We can't simplify that, so we stop there. The next one is like a quadratic. You can see we've got two pairs of terms inside brackets and they're multiplied together because there's no addition sign or subtraction or anything like that in between them. So we're going to use FOIL. So the first term is 1 times root 3, which is root 3. The outer terms, 1 times minus 2, makes minus 2. The inner terms, well, we've got the same idea as we had in the previous example where you times a root by itself. So root 3 times root 3 is just going to be 3. And the sign is positive because they're both positive terms. And the last terms, we've got a root 3 times minus 2 is minus 2 root 3. So we've expanded our brackets now. We're now going to simplify by gathering the like terms. So if we look at the constants first of all, we've got a minus 2 and a plus 3. Minus 2 add 3 just leaves us with 1. And then we've got a root 3, take away 2 lots of root 3. So 1 lot of something, take away 2 lots of something is minus 1 lot. And again, just like with algebra, we don't need to write 1 lot of root 3. We're just going to write that as root 3. So 1 minus root 3. This next question deals with the idea of what we call rationalising. Now at the moment, you'll see we've got an algebraic fraction, or a surd fraction, and the idea here is that we don't like a surd on the bottom of the fraction, because the bottom of a fraction should be how many parts you're sharing something into. So it should be an integer, it should be a whole number. At the moment, we can't really fracture something up into root 3 parts. So what we need to do is manipulate the algebra, but still keep the value the same, to make sure it looks nicer mathematically speaking. So what we're going to do here is we're going to use equivalent fractions. So whatever we do to the bottom, we're going to do to the top. And we want to try and make this bottom value, this denominator, a whole number, an integer. We want to times it by something to make it that integer. And using the application of the idea of timesing a surd by itself to make it a nice whole number, because it's root 3 on the bottom, I'm going to times it by root 3 on both the bottom and the top of the fraction. So dealing with the bottom term, because that's the one that we've been trying to manipulate to make into an integer, root 3 times root 3 is just 3. And on the top, well, we've got to times both of those terms by root 3. So we've got to do 1 times root 3 is root 3. And root 3 times root 3, again, we've met this a few times now, that's just going to give us 3. And at this point here, we can't simplify that any further because the top two terms can't be divided by 3 to simplify, and we've got no common factors to cancel out, so we're fine there. That's our answer. Next one, a little bit harder still now, the idea of simplifying terms. Now at the moment, you can see we've got different surds. So the idea is to try and get them to look like the same surd. Now, the only rule we've got at the moment is to simplify those surds by cancelling them down. So if we think about root 50, first of all, we're looking for the highest square factor of 50, which is 25. So that's root 25 and root 2. Now underneath that, I'm just going to write that as 5 root 2, because the square root of 25 is 5. The next term then is root 8. And again, the highest square factor of root 8 is root 4. And root 4 times root 2 would give us root 8. So again, underneath that, I'm going to write that as 2 root 2, because that's what root 8 would simplify to. And then finally, we've got root 32. Well, the highest square factor of root 32 is going to be root 16 and root 2, because 16 times 2 is 32. And again, if we simplify that, root 16 is 4, so that's 4 lots of root 2. So then we've got, now we can see we've got 3 surds which all have the same root. And so we know when we add and subtract terms, we just change the coefficient at the front, or the multiple of that at the front. So 5 add 2 makes 7, take away 4 makes 3, so that's 3 lots of root 2, and we're simplified. For our final question then, this is the idea of using and applying some of our exact surd values, which is pretty darn hard, to be honest. So you'll see here, we're going to try and simplify tan 30 add tan 60. Now again, these are these stupid trig values that you need to learn for some reason or other. Now tan 30 is root 3 divided by root 3. Heaven knows why I know that, but I do. And sine 60 is root 3 divided by 2. And again, it's a strange old fact that I've learned somehow, which you'll need for your GCSE maths. And what I'm now going to do is I'm going to use my fractions. I'm going to use my wigwams because I'm adding fractions. And if you times across the bottom, we've got a 6. If I times to the top left, I've got 2 lots of root 3. If I times across to the right and put a plus because that's what's inside my wigwam, that gives me 3 lots of root 3. And that would give me 5 root 3 divided by 6. So the exact value of tan 30 add tan 60 is 5 root 3 over 6. And if you want to check that, go ahead on your calculators. Thank you.